Identify if the function shows exponential growth, decay, or neither. And if it does, identify the initial value a, the growth decay factor r, and then evaluate the function at x equals 4 to 2 decimal places. So at the top here, put all your notes, pause the video. A lot of notes, let me go through it. A cannot be 0. B cannot be 1, and B cannot be negative, so it needs to be positive. If you find that B is between 0 and 1, whether it's expressed as a fraction or a decimal, then it is called decay, and your R value, let me fix this, your B value is 1 minus R, and if it's a B that is larger than 1, then we call it growth, and your B, your base, is 1 plus R. So let's see if we can identify this. Well, right off the bat, does this hold true? Yes. And then we say, well, is your base larger or smaller than 1? In this case, it is larger, so we say it's growth. In this case, it's check. Check, right? All three of these check off. And so it is smaller one, so we call it decay. In this case, check. Oops, that is not a check. It does not hold true for this one. B must be larger than 0. Another way of saying that is B must be positive, and it can't be 0, and it can't be 1. So we're going to say not growth or decay. Now, identifying your A is easy if you know your formula, y equals A to the B, A times B to the X. Well, then A is whatever's in front. A is whatever's in front. And then your R, well, we have to think about this a little bit. Since this is growth, I'm going to be using B equals 1 plus R. I'm going to say 3.75 equals 1 plus R. And then I'm going to say that R equals 2.75, which is the decimal form, which is 275%. That's a 275% growth rate. Now the decay rate, since it is decay, my base is equal to 1 minus R. And since this is my base, I'm going to say 0.825 is equal to 1 minus R. Solve for R. You get, let's see, minus 1, negative R equals a negative number. 0.175 is your actual R. In percent form, we move it to the right, 17.5% decay rate.